In this video, let us see about maximum power transfer theorem. According to maximum power transfer theorem, in a linear bilateral DC network, the maximum power is delivered to the load when the load resistance is equal to the source resistance. It means that when you have a source and R is the internal resistance. So when this internal resistance is equal to load resistance, the load resistance will be able to receive maximum power, or the power delivered to the load will be maximum when RL is equal to the source resistance. So let us verify that maximum power transfer theorem. So we have a source, voltage source, and its internal resistance is this small r. What is IRL? IRL equal to Vs divided by total resistance. So R plus RL. What is the power delivered to the load? Power is equal to I square into this RL, that is the load resistance. So substitute here. So this is the power delivered to the load. Now let us derive the condition at which you will get maximum power will be received by the load. So this is the power formula, and now we have to find the condition for maximum power. So for any function, how to find the maximum point? So if this is a function, the maximum value will be when its derivative will be equal to 0. So in this case, you have to find what is dP by dRL, that is you are differentiating the power with respect to the load resistance, and if that is equal to 0, we will get the condition for maximum power. Now we have the function for power. You see here in both in numerator as well as in denominator we have RL. So this is of the form U by V. Dash represents differentiation. So this is the formula. So take Vs square out. So U here is RL and V is R plus RL the whole square. So differentiation of RL will be 1 because we are differentiating the function with respect to RL. So 1 into V, V is this one. So it comes here as such, minus U is RL into V dash. So differentiation of this one is 2 times R plus RL divided by V square. So V is this one, square it, you will get 4 equal to 0. Let us simplify this one. So you will get the condition RL equal to R. So it means that when you have a voltage source in series with the resistance, internal resistance R, this load will receive maximum power when this load resistance is equal to the source resistance. So this is the condition for receiving maximum power. So you take a plot between power and load resistance. You keep on changing the load from 0 to infinity and you plot the graph. You will get a graph like this. At one point the power will be maximum. So that point is the point where the load resistance is equal to the internal resistance R. Now you have to note one thing, RL equal to R. It means that here also you are getting 10 ohms, here also 10 ohms. So whatever power, input power is there, or whatever the voltage is here, it will be dropped here and dropped here equally. So the efficiency will be only 50% at that time, because part of, that is half of the voltage will be dropped here, half voltage will be dropped here equally. So efficiency will be only 50%, but the load receives the maximum power. Now, when you have a complex circuit like this, we have already seen any complex network, linear network can be replaced by a Thevenin network. So VTH and RTH will be there. So in this case, the load will receive the maximum power when load resistance is equal to the Thevenin resistance. Now let us find the formula for the maximum power. So source with the internal resistance R is there. We have already derived this condition RL equal to R for maximum power transfer. And if you have a Thevenin equivalent circuit, RL should be equal to RTH. Now let us do the formula. IRL, current through the load, is equal to Vs divided by R plus RL. And what we have derived for maximum power transfer, RL should be equal to R. So substitute RL instead of R, I am substituting RL. So it becomes 2RL. Power is equal to I square into R. So you square this one. What you will get? Vs square divided by 4RL. So the formula for maximum power is Vs square divided by 4RL. In case of a Thevenin circuit, it will be VTH square divided by 4RTH. So you remember this formula, it is useful for most of the problems. Now let us solve some problems. First one, find the value of RL necessary to receive the maximum power in load. And then find the maximum power delivered to the load RL. So two questions are there. First, we have to find what is the value of RL. So what is the value of RL for maximum power? It means that we have to find the Thevenin resistance. Then second question, we have to find what is the maximum power delivered to the load. That is how many watts. So formula is P max is equal to VTH divided by 4TH. So in general, we have to find what is RTH as well as what is VTH. Both Thevenin voltage and Thevenin resistance we have to find. So first we will find what is the Thevenin resistance. So let us short circuit the sources and find the Thevenin resistance. So shorted, source is shorted and you find the resistance. Resistance we should always find from the opposite direction. So RTH is equal to 300 into 100 because both are in parallel, divided by 400 plus this 75. So this comes around 150 ohms. So Thevenin resistance is 150 ohms. Or this RL, when it is equal to 150 ohms, it will receive the maximum power. Now the second part is to find the maximum power. The formula is P max is equal to VTH square divided by 4 RTH. Already we found the Thevenin resistance. Now we have to find the Thevenin voltage. So Thevenin voltage is nothing but open circuit voltage. So we have to find the voltage here. Now what is this voltage? The voltage across the 100 ohms is the Thevenin voltage. So VTH is equal to 100. This 100 is for this total voltage into this resistance divided by total resistance. Because 25 ohms and 50 ohms there is no current because circuit is open. So we are finding the voltage across 100 ohms. So that comes around 25 volts. So what is P max formula? You substituted. So 25 volts, 25 square divided by 4 into RTH is 150. So this is the power. So this is the maximum power delivered to the load. Now let us see another problem. Find the maximum power delivered to the load resistance R. You see R is here. Okay. So whenever you read the problem, read it carefully, because don't think always load resistance will be given here. It is here. Okay. In this case it is given here. Load resistance is here. So you need to find what is the maximum power delivered to the load resistance R. So same thing, you find the Thevenin parameters VTH and RTH. So let us find first Thevenin's resistance. So for finding Thevenin resistance, you have to remove all the sources, short circuit the voltage source and open circuit the current source. So you have two resistance in parallel. See, 10 ohms and 6 ohms are in series. So you can add it. So it becomes 16 ohms and 25 ohms is here. So if you find RTH, these two are in parallel. So you will get RTH directly. So this is the Thevenin resistance. Now let us find the Thevenin voltage across this terminals A and B. So we should open circuit the terminals and find it. Now these two resistance 25 ohms and 16 ohms, that is this 10 and 6 ohms are in series. So I have added it. So it becomes 16 ohms, and now these two are in parallel. So find the parallel resistance. Now we have found the equivalent resistance. Let us draw the circuit again. So 3 amps current source is in parallel with this resistance. So this current source in parallel with the resistance can be transformed into a voltage source in series with the same resistance. So I am doing source transformation. So 3 into this resistance 9.756 will give you 29.268 volt. So this voltage source is in series with this same resistance. See, you see the current direction arrow, it is upwards. So your polarity of the voltage source should also be like this, that is positive upward. Then you have another voltage source here, that also you mark it here. Now you have two voltage sources, so but they are of opposite polarity. So you can subtract these two voltages, you will get 9.268, and final polarity should be the polarity of the highest voltage. So in this case, this should be, this 29 is the highest value. So the polarity of your final one should be positive here and negative towards B. So this is the Thevenin voltage VTH. Okay. Now let us find the maximum power formula. Apply the maximum power formula. VTH is there, 4 into RTH. Already we have found RTH. So this is the maximum power delivered to the load. So the points to remember here are, in a linear bilateral DC network, maximum power will be delivered to the load when the load resistance is equal to source resistance. In case of a Thevenin circuit, RL will be equal to R Thevenin for maximum power transfer. And the formula for maximum power is VT square divided by 4 RTH. If you like the material, do subscribe to Read Electric Vehicle channel. Thank you.